Hi, sixth graders. Here we are ready to do our second online math class. As you know, in chapter 10, we are doing the area of different polygons. So today we're going to take two. We've done triangles. Now we're going to do parallelograms and trapezoids. And so they have two different formulas, and so we're going to look at what they are and how to find the area of both parallelograms and trapezoids today. So first of all, what is a parallelogram? Well, there are several different things that are parallelograms. So parallelograms are any shape that all of their sides are parallel to each other. So square, rhombus, that's just your basic parallelogram, and a rectangle would all be considered parallelograms. And again, it's because these are parallel and these are. These are and these are. These are and these are. And then these and these. So anything that all the sides are parallel is going to be a parallelogram. So here are parallelograms. And the area formula that you want to add to your notebook for parallelograms, very easy, is area equals base times height. Okay, area equals base times height. And so here is just your basic parallelogram. Your base is 8. Okay, so here's our base, and it's 8, just like we talked about. How many squares do you pass? 8. And the height is inside here, and again, it's going to be in that invisible line. The height is going to be 5. Okay, sometimes you can also find the height here as well. Sometimes if a parallelogram is tilted far enough this way, you're going to have to find the height out here. But the height right here, 5, the base is 8. Again, you just multiply the two together, and so 8 times 5, and since this one's on the graph, this would be 40 units squared, would be the area of this parallelogram. So pretty easy on the parallelograms. Okay, then we also have trapezoids, okay? Now what makes the trapezoid different from a parallelogram and makes it have its own formula to find the area is that parallelograms, again, have everything parallel to each other, and the trapezoid does not. Okay, the trapezoid has this and this parallel, but these two are not parallel to each other, and so they have, a trapezoid has its own special formula. Okay, so the trapezoid, most of the time, this is what you think of when you see a trapezoid. That's just your basic trapezoid, and a lot of times it will look like that. But it can also look a couple of different ways. It can also look like any of these. Any of these would be considered a trapezoid. And again, as long as two of its sides are parallel, but two of them are not, then that would be a trapezoid. So it could look like any of these things right here. Again, as long as two are parallel and two are not, it would be considered a trapezoid. And so these are all different forms of trapezoids. Now, trapezoids, like I said, they have its own formula. Okay? So you're going to want to put this in your math notebook as well. So when you look at a trapezoid, okay, and you might want to draw this in your notebook, they have two different bases because one of their bases is always going to be longer than the other one. Okay, one base is going to always be longer than the other one. So this one up here is called base sub 1, and this one down here is called base sub 2. And then your height is going to be inside here. Okay, so base sub 1 and base sub 2. And then the area formula for the trapezoid is area equals half the height, and then in parentheses, and then the addition of base 1 and base 2. So you would take these two bases and add them together. They would be this number. The height would be here, and then half. So area equals half times the height times base sub 1 plus base sub 2. Okay? So that's the area formula for the trapezoid. So let's try some parallelogram and some trapezoid problems. So if you will grab a sheet of paper, and we will do a few of each kind of problem. So let's start with the parallelogram. Again, super easy. It's just area equals base times height. Okay, so area equals base times height. Okay, so let's say that we have a parallelogram. Okay, and again, our height is going to be right here. Okay, so we have a parallelogram, and this is going to be 4 centimeters. Okay, and this is going to be 8 centimeters. Okay, so again, super easy to find the area of a parallelogram. You just take the base and multiply it by the height. Okay, we know that 8 times 4 is 32. And again, since it's area, we're gonna have 32 centimeters squared for our area of this parallelogram. Okay, pretty easy. In a few minutes, we'll do a couple of these on the coordinate plane as well. But let's look at a trapezoid. Okay, let's look at finding the area of a trapezoid. So let's say that we have a trapezoid. And let's see which one we want to do. Okay, let's do this one. All right, so we have a trapezoid, okay? And again, remember the formula for it is area equals half the height times the addition of the two bases, okay? And again, base sub 1, base sub 2, and our height is gonna be inside here, okay? All right, so on this one, we're gonna have the base sub 1 is gonna be 11 centimeters. Okay, base sub 1 is gonna be 11 centimeters. Base sub 2 is gonna be 21 centimeters. And our height is going to be 13 centimeters. Okay, so the first thing we need to do is get all of this information. So area equals half, so we're gonna have our half. Our height is gonna be 13. Okay, and then we add our two bases together, so we're gonna add 21 to 11. Okay, add 21 to 11, and that's gonna give us 32. Okay, and then this is just like when we did triangles. You're gonna have a couple of choices of how to get the answer, but the fastest way to get the answer to this problem is probably gonna be to do this. To take half of 32, okay, which hopefully you know from memory, half of 32 is 16. So we would take 16, multiply it by 13. Okay, 16 multiplied by 13, and that is gonna be the area of our trapezoid. So I'll give you a minute to do 16 times 13 and see what you get. Okay, 16 times 13. And again, since it's area, we know the answer will be whatever the answer is, centimeters squared. So 16 times 13. Okay, hopefully you got 208 centimeters squared. Okay, 208 centimeters squared would be the area of our trapezoid. Okay, let's try another one. Okay, so again, we're gonna have our trapezoid. Okay, we're gonna have our height in here, base sub 1, base sub 2, and again, we know our formula is area equals half the height times the addition of the two bases. Okay, on this one, our base is gonna be, base sub 2 is gonna be 25 feet. Okay, our base sub 1 is gonna be 13 feet. And our height is going to be 39 feet. Okay, so again, just like last time, we're gonna take the information and plug it into our formula. Okay, so area equals half, so we have half. Our height is 39. And then we need to add our two bases together. So we have 25 and 13. So when we add 25 and 13 together, that will be 38. Okay, and again, you have a couple ways you could solve this problem. You could go ahead and multiply 39 times 38, which is gonna be a really big number, and then half it. You could half 39, which is gonna be a decimal. You don't wanna do that, and multiply that by 38. Probably the fastest thing to do is just to go ahead and half 38, because it's an even number. We know it has an exact half. Half of 38 would be 19. And so simply take 19 and multiply it by 39, and we have the area of our trapezoid. So I'm gonna give you a minute to do 19 times 39, and let's see what we would get for the area of our trapezoid. So 19 times 39. Okay, and again, remember our answer is gonna be feet squared because it's area. Okay, 19 times 39. Okay, hopefully you got 741 feet squared. Okay, 741 feet squared for the area of this trapezoid. Okay, So now we're gonna go to the coordinate plane and we're gonna look at how to find the area of both parallelograms and trapezoids on the coordinate plane. So again, hopefully you have a few coordinate planes made up ahead, but if you don't, go ahead and make a coordinate plane. Of course, I'll have to make mine. So X and Y axis. And then let's go ahead and number out to 10 if you haven't already numbered out to 10. Because I think one example I'm going to use goes out to 10. Okay, and we'll start with parallelograms, and then we'll do some trapezoids. Okay, so again, we'll start with parallelogram, and so I will just give you some 4 points. We will put them on the graph, we will connect them, and we will have a parallelogram, and then we'll find the area. Okay, so your first point is gonna be at 1, 1. Okay, so again, over 1, up 1. Okay, 1, 1. Our next point is gonna be at 7, 1. Okay, 7, 1. And then our next point is going to be 3, 6. 3, 6. Okay, and then our last point is going to be 9, 6. Okay, 9, 6. Okay, we're gonna connect these. Okay, and we will have a parallelogram. And so we need to count our base and our height. Okay, so just like when we had triangles, we're gonna start here. We're gonna count over to here, so how many squares we pass, and that's gonna be our base. So we start here and we go 1, 2, 3, 4, 5, 6. So 6 is gonna be our base. Okay, 6 is gonna be our base. And then our height's in here, it's invisible, but it comes straight down to the base. And so here, we're gonna count how many it takes us to go from here down. So we're gonna go 1, 2, 3, 4, 5. So our height is gonna be 5, okay? And remember that with a parallelogram, the area is simply base times height. So this should be super easy. 6 times 5, we know that that is 30. And again, since it's on the graph, it's gonna be units. So 30 units squared is going to be our area, okay? One thing you'll notice on a parallelogram is that here to here and here to here always have to be the same length in order for it to be a parallelogram. So again, we found that this was 6, 1, 2, 3, 4, 5, 6. And so this is also gonna be 6. 1, 2, 3, 4, 5, 6, okay? And so you're gonna need to know that to be able to do the next problem that we're gonna do, okay? So again, you might wanna go to a different coordinate plane, and I need to fix a couple of numbers really quickly. Okay, so this time I am going to give you 3 of the 4 points of the parallelogram, and you're gonna figure out the missing ordered pair, okay? So let's put these points on the coordinate plane. Okay, so our first point is going to be 0, 1. So 0, 1, so it's gonna be right there. So 0 up to 1, okay? Our next point is gonna be -4, -4. So over -4, down -4. Okay, -4, -4. And then our last point is gonna be -1, -4. So over -1, down -4, okay? And then let's connect those like this. So we're gonna start with our first point that we put on here. We're gonna connect it down to this point, and then we're gonna connect that to this point, okay? Now, we are missing our last point, which is gonna be over here somewhere, because we need this to be a parallelogram. And so Again, remember we talked about that however long this is, okay, this needs to be the same length, okay? However long this needs to be the same length. So see if you can figure out where our last ordered pair would be to make this a parallelogram. Okay, so see if you can figure out where our last point would be. Okay, hopefully you realized, okay, well this is 1, 2, 3. And so this one also needs to be 1, 2, 3, which would mean our missing point is right there. So our missing ordered pair would have been 3, 1 to make this a parallelogram. And so here we have our parallelogram, okay? And so again, we already know our base is 3. We just said that, okay? Our base is 3. And this is an example of what I mentioned a little bit earlier, that because this parallelogram is sort of tilted this way so much, we're gonna find our height right here. Okay, so just like the triangle that leans back and you find the height out here, we're gonna find the height right here. Okay, so the height's gonna be right there, so it's gonna come down to where the base would be if it came out this far. And so we're gonna look at the height. And so we go 1, 2, 3, 4, 5. Okay, so our height is 5. So our base is 3 and our height is 5. Okay, and again, easiest of all the polygons to find the area, base times height, 3 times 5, 15, and it's on the graph, so it is 15 units squared. Okay? All right, now let's look at let's do some trapezoids on the coordinate plane, okay? Some trapezoids. So again, hopefully you already have a coordinate plane made, but let me fix mine real quickly. Okay, so we are going to put some trapezoids on the coordinate plane. Okay, so let's see, for our first one, let's do this one. So your first point is going to be 1, 1. Okay, so over 1, up 1. All right, 1, 1. Okay, our second point is going to be 10, 1. Okay, so over to 10, up to 1. Okay, so 1, 1 and 10, 1. Okay, our next point is going to be 3, 5. 3, 5. Okay, and our last point is going to be 7, 5. 7, 5. Okay, we're going to connect those and we will have a trapezoid. Okay, and remember our area formula for the trapezoid is area equals half the height times the addition of the two bases, okay? So we need to figure out what all of those are on this trapezoid, okay? So first of all, let's count our bases. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so base sub 2 is 9 units long. And then we need to see how long the base of 1 is. So this one is 1, 2, 3, 4. Okay, so it's 4. So this one's 4 and this one's 9. So again, remember here we need to have the addition of the two bases. So if we add 9 and 4 together, we're going to get 13. And so 13 is going to be the addition of the two bases together. And then let's find the height. Okay, the height is going to be 1, 2, 3, 4. Okay, so our height is 4. Okay, so the area of this trapezoid is going to be half times the height times the addition of the two bases. The fastest thing to do here, since we know that half of 4 is 2, take 2, multiply it by 13. Okay, 2 times 13, we know that that is 26. And again, since it's on the graph, it's going to be 26 units squared for the area of this trapezoid. Okay, let's try another trapezoid. Okay, so another trapezoid, I'm going to leave the formula here. Okay, area equals half the height times the addition of the two bases. Okay, let's try another trapezoid. Okay, let's do a trapezoid that is sideways. Okay, so we're gonna do a trapezoid that is sideways. Okay, so let's put our points on the graph and make us a trapezoid. Okay, so your first point is gonna be at -3, 3. So negative over -3, up 3. Okay, so -3, 3. Okay, our next point is going to be at -3, 0. So going over to -3 and then not going anywhere. So -3, 3, and then -3, 0. Okay, our next point is at 1, -4. So that's over 1 down to -4. Okay, 1, -4. And then our last point is at 1, 4. So over 1, up 4. Okay, so we're going to connect all of that. Okay, and you can see we have a trapezoid that's sideways. Okay, so our base sub 2's here, our sub 1's here, and our height is going to be inside it. And since you have paper, you could actually turn your paper to where it's sitting on its base if you want to. Obviously, I can't do that with my whiteboard, but if you want to do that, you can. And so again, all we need to do is count our two bases, and we need to count the height. Okay, count our two bases and count the height. So let's do that next. Okay, so we are going to count our two bases. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that base is 8. And then the little base, the base sub 1 is 1, 2, 3. So the little base is 3. Okay, so again, remember we add the two bases together. So 8 plus 3, we know that that is 11. So we're going to put 11 down here in our formula for the two bases added together. And then let's find the height. So again, the height's going to be in here. Okay, the height's going to be in here. And again, you can turn your sheet where it's sitting on its base if you want to. And so the height is going to be 1, 2, 3, 4. Okay, so our height is going to be 4. And then we know that we have half here. So it's half times the height times the addition of the two bases. And easiest thing to do would probably be just to say half of 4, that's 2, multiply it by 11, and we're going to get 22 units squared for the area of our trapezoid. Okay? All right, let's look at one more thing, and this is similar to what we did when we had triangles. Sometimes you're going to be given different parts of a parallelogram or a trapezoid, and you've got to figure out what is missing. And so that's what we'll do next. So let's say that we have a trapezoid. Okay, we have a trapezoid. And let's say that we know that the base of 2 is 22 centimeters. Okay, and we know that the base sub, did I say base sub 1? Base sub 1 is 22 centimeters, and the base sub 2 is 38 centimeters. Okay, we know those two things. We do not know the height. Okay, we do not know the height, but we do know the area is 660 centimeters squared. Okay, we do know that. Okay, so we're going to do just like we did with the triangle. We're going to take our formula and we're going to plug in what we do know. Okay, so again, our formula for the trapezoid is area equals half the height times the addition of the two bases. Okay, so here we know the area. We know that the area is 660. Okay, the half is going to stay there. The height we do not know, so it's going to stay in H. But then we need to add the two bases together. So we have 38 and 22. Okay, 38 and 22, and so we need to add those two things together. So what do we get when we add 38 and 22? Okay, 38 and 22. Okay, hopefully you got 60. Okay, 38 and 22 equals 60. And so, just like we did when we had triangles, we look over here and we have half. We have an h we can't do anything with, but we have 60, and we can do half of 60, which we know is 30. So all we have left over here is 30h, and what we have left over here is 660. Okay, so we have an equation. And so again, we know if we multiply by 30 here, we're going to take it over here and divide. So that means that we need to put 30 into 660. Okay, 30 into 660 to see what our missing height would be. And so we'll give you a minute to do that. And let's see what our height would be. So 30 into 660. Okay, hopefully you got 22. Okay, so 22. So 22 centimeters would be our missing height. Okay, 22 centimeters would be our missing height. Okay, let's do one more problem like this. And so again, we're gonna have a trapezoid. Okay, and we're gonna have our trapezoid formula. Area equals half the height times the addition of the two bases. And then we're going to be given some information, and we need to figure out what would be the missing information. Okay, so on this one, we're going to be given the base sub 2 is going to be 15 centimeters. Okay, the base sub 1 is going to be 7 centimeters. Okay, we don't know the height. Okay, we do not know the height. But we do know that the area is 110 centimeters squared. Okay, so we're going to do just like we did in our last problem. We're going to take the information that we do know and put it into the formula. Okay, so we're going to take the information we do know. So we do know the area. So we're going to put that here instead of A. So that's going to be 110. We're going to put our half. We're going to put our H because we don't know it. And then we need to add the two bases together. So 15 plus 7. Okay, 15 plus 7. Okay, hopefully we know that that is 22. So we're going to get 22 here. Okay, so then we need to do what we can on this side. We can do half of 22, which we know is 11. So that's going to leave us on this side with 11h and on this side with 110. Okay, again, we have an equation. So we know if we're multiplying by 11 here, we've got to bring it over here and divide. So you'll be putting 11 into 110. Okay, 11 into 110, which we know is 10. And so our missing height is going to be 10 centimeters. So I think that's everything that we need to know about finding the area of parallelograms. Remember, the area of parallelograms are base times height. And then finding the area of trapezoids, you will use area equals half the height plus the addition of the two bases. So there we go.